Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, in last session we learned a very important fundamental laws of chemistry. Today we are going to start with the Dalton atomic theory. But before the session, we first revise the last session with that we learned fundamental chemical laws in which we learn three chemical laws. That is, we first learn law of constant proportion, that is, all samples of a compound have the same composition, that is, the same proportion by mass of its constituent elements. Secondly, we learn law of conservation of mass, where it states that total mass of a substance present after a chemical reaction is the same as the total mass of a substance before the reaction. That is, matter is neither created nor destroyed in the chemical reaction. Thirdly, we understood law of multiple proportion, where if two elements form more than a single compound, the masses of one element combined with the fixed mass of the second are in the ratio of small whole number. I gave you the example of carbon dioxide and carbon monoxide in the last session. We also learned the discoveries of atom timeline, that is, Democritus first coined the name atom, then Dalton, then Thomas, Rutherford, Bohr's modern quantum cloud model. They all gave the different discoveries of atom and its subatomic parts. Now, this session we are going to study Dalton atomic theory. We'll be learning application to law by Dalton atomic theories. We'll also be understanding modern atomic theory. Friends, what is Dalton atomic theory? Who is Dalton? Is it any number or is it any person's name? Yes, let's find out what is Dalton atomic theory. Yes, Dalton is a scientist, or you can say he was the English chemist, physicist, or meteorologist. He was born in Eaglesfield, Cumbria in UK. He is the first who gave the scientific theory about the structure of matter in 1808. He also proposed this atomic theory and law of multiple proportion. Basically, he is the only person who explained the law of constant proportion and conservation of mass by his atomic theories. Now let's discuss what is his atomic theory. Dalton's atomic theory was given in 1803. He postulated many points. Let's discuss one by one. He says that all the matter is made up of very tiny particles called atoms. Second, atom cannot be divided. Atom can neither be created nor destroyed. Atoms are of various kinds. There are as many kinds of atom as are elements. All the atoms of a given are identical in every respect, having same mass, size, and chemical properties. Atoms of different elements differ in mass, size, and chemical properties. Chemical combination between two or more elements consists of joining together of the atom of these elements to form molecules of a compound. He also postulated the number and the kind of atom in a given compound is fixed, where he also says that atoms of the same element can combine in more than a one ratio to form more than a one compound. So let's see the pictorial form of chemical composition of matter. We already know that what is the chemical composition of matter, that is elements, compounds and mixture. So let's see then. With respect to atomic theory, element we say one kind of atom. In compound we say two or more elements chemically bonded, chemically different than elements. What are mixtures? According to atomic theory of matter, There are two or more substances together, that is, they are physically together, they are not chemically combined together. So each maintains its chemical identity, right? We know that this Dalton atomic theory have explained the laws. How? Have you ever thought, how can the law of conservation of mass and the constant proportion can be explained? Why do the elements behave as they do? To discuss and to explain, Joel Dalton in 1803 to 1808, he proposed this theory of Dalton atomic theory to explain these laws. Let's revise or let's explain one by one. That's law of conservation of mass. According to Dalton, he says each chemical element is composed of minute indestructible particles called atoms. He also says that atoms can neither be created nor be destroyed by chemical changes. So let's explain how. Here we write mass conservation law, which actually says that mass of reactant is equal to mass of product, right? So according to Dalton, he says that if the atom can neither be created nor be destroyed, let's write down, if atoms of an element are indestructible, then the same remains unchanged when in chemical reactions, right? So this explains the law of conservation. Let's take an example and see how. So this is an example of a water molecule where you can see here the chemical reaction. We have two molecules of hydrogen combining to two molecules of oxygen. Here you can see the mass of reactant is equal to mass of product, where here you can see four molecules of hydrogen atom. Here 2 plus 2 is 4, plus 2 oxygen atom, here 2 oxygen atom, here 4 hydrogen and 2 oxygen. So mass of the reactant is always equal to the product, right? So here he explains this law. So let's understand the second law, that is the law of constant proportion. According to Dalton, he says all the atoms of an element are alike in mass or the other properties, but the atoms of one element are different from those of other elements. He also says that in each of these compounds, different elements combine in a simple numerical ratio, right? So let's explain again. Here we know that the law of constant proportion What is that? It means that the sources can be different, but the composition of a compound will be same. How? This is a law of constant proportion. We know that it is also called Prost's law or definite proportion. That is law of definite proportion. According to Dalton, he says if all atoms of an element are alike in mass, that is the second assumption we took there, and if atoms unite in a fixed numerical ratio, that is the second, or you can say the third in the list, that is the percentage composition of a compound must be unique, right? Regardless of the source of the compound. This actually explains the law of constant proportion. I wish you have remembered, I gave you the example of glass of waters to be taken from the many other sources, like one glasses of tap water from lake, from pond, from river, and if we see from the laboratory test, every water had the same molecule. That is, this is here you can see it's a water molecule forming when hydrogen combined with oxygen. Hydrogen combining with oxygen here. See, if you take these hydrogen, these are the reactant part, and this is the water molecule. That is, whatever be the source of the compound, the constituent particles of the element will be same. That is, from wherever you take the water from you can take from the river, you can take from the pond, you can take your tap water. The water molecule will contain hydrogen and oxygen. This is fixed. I hope you understand now both the laws which was explained by the Dalton atomic theory. Let's go back to the laws. Here is the theory and the explanation by the Dalton atomic theory. Now let's come to the drawbacks. Every theory has bits of the drawbacks. See, here the atomic theory was firstly discovered that the atom is the very small particle which made the matter, but it does have many drawbacks, though we have to learn these. That is, atom is thought to be indivisible. How? that this is one of the major drawback of a Dalton atomic theory of matter is that atoms were thought to be indivisible. Why? As we know that under special circumstances, atom can be further divided into still smaller particles called electrons, protons, and neutrons. So atoms are themselves made of three particles, right? Secondly, it failed to explain many common observations like different properties of charcoal, graphite, and diamond. That is, um, as we know, they are made up of all the carbon atoms. Still, they have failed to give the different properties of charcoal, graphite, and diamond. It also says that all the atoms of an element have exactly the same mass. As if now we know that atom of the same element can have slightly different masses also, right? It also have the drawback that this theory says that the atom of a different element have different masses. Though we know that even atoms of different elements can have the same masses also. So let's come to the modern atomic theory, which gives the broader view of the atomic theories. So what are these? It says all atoms have a similar basic structure. That is, it has the subatomic particles. We call it electron, proton, and neutron. Secondly, it says atom can composed of many particles that are electron, proton, and neutron, which I have already told you right now. It also says that atom can be created and destroyed by nuclear fusion and fission processes. It also says that atom of an element may not be alike in all respects, as is seen in cases of isotopes. Though modern atomic theory also describes that in the formation of organic compounds, the law of chemical combination are not always followed. I hope you have understood this session of Dalton atomic theory and the modern atomic theory. So this is the activity for you. You have to just give the three differences between the Dalton atomic theory and the modern atomic theory. Can you give me the differences in 5 to 10 minutes? Thank you. So in next session, we'll be studying structure of atom, in which we'll be giving you details of mass number and atomic number. So let's meet in the next session. Thank you, friends.